Historical context of trigonometric terms. Welcome, everyone. Before we dive into the calculations and the trigonometry formulas you'll see in your textbooks, I want us to take a moment to look at the bigger picture. Often, when we study mathematics, we tend to view it as just a dry collection of formulas and rules to be memorized for an exam. But there is so much more to it than that. The terms we use every single day in class, terms like sine, cosine, and tangent, didn't just appear out of thin air. They are actually the beautiful result of centuries of global collaboration and linguistic evolution, passed down through different cultures and languages. As we move through this lesson, I want you to keep this in mind. Understanding where these terms come from helps us appreciate trigonometry not just as a classroom subject, but as a powerful, practical tool. These were the very instruments developed by ancient astronomers and mathematicians to decode the mysteries of the universe. So, let's begin our journey by looking at how the word sine itself traveled across the globe. The evolution of the term sine. Now, let's dive into the heart of our topic. As I mentioned on the previous slide, trigonometry isn't just a set of rules, it's a global legacy. Nowhere is this more evident in the word sine itself. It has had one of the most fascinating journeys in mathematical history, traveling across various languages and cultures over many centuries. Let's trace this journey step by step. First, we look at the ancient Indian origins. The entire concept actually began in India. A brilliant mathematician named Aryabhata used the term ardhajaya, which literally translates to the half-chord of a circle. As mathematical practices evolved, this term was simplified and shortened to just jaya or jiva. Next, we move to step 2, the translation to Arabic. As Indian mathematical knowledge spread, these texts were translated into Arabic. During this process, the word jaya was transliterated into Arabic as jiba. Now, here is a crucial detail. In traditional Arabic writing, vowels are often omitted. Because of this, the word appeared in written form simply as JB. This leads us to step 3, the translation to Latin, where a bit of a linguistic misunderstanding occurred. When European scholars later began translating these Arabic texts into Latin, they encountered that JB notation. They misinterpreted it as the Arabic word jayb, which refers to a bay, a pocket, or a fold, much like a fold in a piece of clothing. Since the Latin word for a fold or a curve is sinus, that is exactly how the term entered the Western mathematical lexicon. And that, class, is why we use the word sine today. Finally, we reach step 4, modern notation. While the name had already traveled through these languages, the shorthand we use in our textbooks today, the abbreviated 3-letter notation, SIN, was actually a much later addition, introduced by the English mathematician Edmund Gunter. So, as we move to the next slide, keep this in mind. The terms we use are not just random labels, but are deeply connected to this rich, interconnected history. The evolution of cosine and tangent. Just like sine, these weren't just invented out of thin air. They were developed to solve very practical, complex problems in the fields of astronomy and geography. First, let's examine the cosine or cos. If you look closely at the word, you'll see it actually contains the word sine. This is because the term is derived from the ancient Sanskrit word koti jaya. In the context of ancient Indian mathematics, the word koti referred to the complement of an angle. So when we say koti jaya, we are essentially talking about the sine of the complementary angle. As this concept moved into English, it was simplified to cosine, which literally stands for complementary sine. Next, we have the tangent, which we write as tan. This term has a much more direct Latin origin. It comes from the Latin word tangere, which means to touch. In geometry, this refers to a line that touches a circle at exactly one single point. But why was this useful? Historically, this was closely linked to measuring the length of a shadow cast by a vertical object, known as a gnomon, onto a flat surface. Now that we've traced the fascinating linguistic journey of the word, sine, from India through the Arabic world and into Latin, let's look at how the other trigonometric ratios, cosine and tangent, came to be. Understanding these origins is crucial because, as we will see in the next slide, these ratios weren't just abstract labels. They were the essential tools used by ancient sailors and astronomers to navigate the seas and map the stars. Real-world application. Why were these terms created? Now that we've traced the fascinating linguistic journey of these terms from Sanskrit to Latin, you might be wondering, why did anyone bother coming up with all this? Why go through the trouble of defining half-chords or complementary signs? Well, it's important to realize that these terms were not created for textbooks or for passing exams. They were created for survival and discovery. Let's look at a real-world example involving ancient navigation and astronomy. Imagine you are an ancient sailor trying to determine your exact position in the middle of the ocean, or an ancient astronomer attempting to calculate the immense distance to a star. The first hurdle, or the problem, was a physical one. You simply could not travel to a star to measure its distance with a ruler. However, they found a solution through the power of trigonometry. By measuring the angle of a star relative to the horizon and applying the ratios of a triangle, specifically using that half-chord or sine we discussed earlier, they could calculate vast, unreachable distances using only a few known, measurable angles. The result of this mathematical breakthrough was revolutionary. It allowed for the creation of highly accurate maps and calendars. These weren't just academic achievements, they were essential tools for managing trade routes and planning agriculture, literally helping civilizations thrive. As we move into our final summary, keep this in mind. Every time you use these ratios, you are using a tool that once helped humanity navigate the unknown. Key takeaways. First, it is vital to remember the concept of global contribution. As we've seen through our journey across the centuries, trigonometry isn't the work of just one person or one nation. It is a beautiful blend of Indian, Arabic, and European mathematical thought. It is a truly international legacy. To recap our specific terms, for sine, we tracked its evolution from the Sanskrit word jaya through the Arabic jiba and finally into the Latin sinus. For cosine, remember that it represents the complementary sign, which stems from that original Sanskrit term, kodi jaya. As for tangent, we noted its roots in the Latin word tangere, meaning to touch, which was originally used in the context of measuring shadows. Finally, regarding notation, keep in mind that the modern shorthand we use today, sine, cosine, and tangent, was standardized much later, specifically to make these complex, large-scale calculations much faster and more efficient for mathematicians. All right, let's bring everything we've discussed today together into a quick summary. Now, before we wrap up, I want to address a few common misconceptions students often have when looking at these terms in a textbook. Common mistakes. First, many students fall into the trap of thinking that these terms, like sine, cosine, and tangent, are just arbitrary, random labels chosen by mathematicians out of thin air. It is easy to view them as just meaningless abbreviations on a page. However, as we have seen throughout this lesson, these terms are deeply rooted in geometry. When you see a term like sine of angle A, I want you to remember that you aren't just looking at a random label. You are looking at a ratio that describes a specific geometric relationship, much like the ancient concept of the half-chord of a circle. In fact, when you see sine of angle A, try to visualize that historical connection, that this ratio was once a vital tool used by astronomers to map the very stars in our sky. Second, there is a tendency to confuse the linguistic history we just discussed with the actual mathematical function itself. It is important to distinguish between the two. For instance, while we learned that the Latin word sinus refers to a curve or a fold, the mathematical function sine of angle A in a right-angled triangle is strictly a ratio of the lengths of two sides. Please, do not let the etymology confuse the operation. The history tells us where the name came from, but the mathematics tells us how the ratio behaves. Now, as we wrap up our journey through the history of trigonometry, I want to address two common misconceptions that students often encounter. By keeping these distinctions clear, you will move beyond mere memorization and truly begin to understand the logic behind the language of trigonometry.